James Webb has a problem. Discover new images of Neptune and Mars. This is the kind of news I never want to give you. One part of an instrument on the James Webb Space Telescope is out of service temporarily. NASA announced JWST has stopped using one of the 4 observing modes on the mid-infrared instrument. What they noticed was increased friction during preparations for an observation. The announcement was made on September 20th, although controllers first noticed the issue on August 24th. I know no one likes it when space telescopes, especially if we are talking about the James Webb, have a problem. But project officials are confident it will not be a long-term one. Let's see it in more detail. After that, we will also see the brand new pictures of Neptune and Mars taken by Webb. Let's go. So one of the 4 observing modes on the mid-infrared instrument, MIRI on JWST, after a mechanism that supports that observing mode, exhibited what appears to be increased friction during preparations for an observation. Is this as bad as it sounds? To understand it, we have to make a step back and see what the MIRI camera is and how it works. This amazing camera is the heart of the James Webb Space Telescope, and it allows us to see the universe as we have never seen it. The infrared domain of the electromagnetic spectrum is not accessible to our eyes because it is made of wavelengths that are longer than our eyes can see. But the MIRI camera can. In this way, its sensitive detectors allow us to see the redshifted light from faraway galaxies, newly forming stars, and very, very faint visible objects such as comets and objects in the Kuiper Belt as well. So this is what MIRI does. But in order to understand what's the issue with JWST, we have to see it in more detail. The 4 observing modes of the MIRI instrument are imaging, low-resolution spectroscopy, coronagraphy, and medium-resolution spectroscopy. NASA explained that this mechanism is a grading wheel that allows scientists to select between short, medium, and longer wavelengths when making observations using the MRS mode. Engineers are still trying to figure out where the root of the problem is, and it might take some time for them to fix everything. Perhaps the smartest thing to do in this case is to switch off the interested observing mode. At the International Astronautical Congress held on September 21st, NASA said they're taking a break and just making sure it works well. Everyone is pretty confident that this won't be a huge problem and it will soon be fixed. The truth is, engineers at NASA are some of the best engineers in the world, and they managed to fix, for example, issues and glitches on board the Voyager probe, the most distant human-made object ever built. So I'm pretty sure they'll find a way to solve the issue with the JWST in no time as well. It just may take some time because everything has to be done from a distance. Unlike what was the case for the Hubble Space Telescope, NASA can't fly a team up to space to repair the JWST. Hubble is in orbit around Earth, which made it feasible to send a shuttle, but the JWST is much farther away, about 1 million miles. It's so far away that it doesn't actually orbit Earth, but instead orbits the Sun. As such, physical repairs aren't an option. The Webb team will have to solve this particular problem remotely. However, all the other observing modes are working as expected, and JWST continues to perform at or above expectations otherwise. During the International Astronautical Congress, the mission released an astonishing image of the planet Neptune. Check it out. This is actually the most detailed look at the distant planet since the Voyager 2 spacecraft flew by it in 1989. Neptune has fascinated researchers since its discovery in 1846. It's located 30 times farther from the Sun than Earth, and it orbits in the remote, dark region of the outer solar system. If you were on Neptune, the Sun would be nothing more than a small and faint disk. Noon on Neptune would be similar to a dim twilight on Earth. Guys, it's cold over there. It makes sense that this planet is characterized as an ice giant due to the chemical makeup of its interior. Compared to the gas giants, Jupiter and Saturn, Neptune is much richer in elements heavier than hydrogen and helium. This is readily apparent in Neptune's signature blue appearance in Hubble Space Telescope images at visible wavelengths caused by small amounts of gaseous methane. Now follow me. Hubble and Webb operate in 2 different ranges of wavelength. This is the reason why Neptune doesn't look blue at all in Webb's images. Also, if you're not an astronomer, you might be wondering why Webb's image displays Neptune's rings while Hubble's doesn't. This is because most of the light coming from the rings of planets emits in the infrared domain of the electromagnetic spectrum. Therefore, Webb is more suitable for this purpose. This is the most detailed picture we have of Neptune's rings. Some of the rings present in this image we have never been able to see before. Methane gas so strongly absorbs red and infrared light that the planet is quite dark at these near-infrared wavelengths, except where high-altitude clouds are present. Such methane ice clouds are prominent as bright streaks and spots, which reflect sunlight before it is absorbed by methane gas. The thin line of brightness you see circling the planet's equator could be a visual signature of global atmospheric circulation that powers Neptune's winds and storms. The atmosphere descends and warms at the equator, glowing at infrared wavelengths. Neptune orbits the Sun in a 164-year orbit, and this means that currently we're not able to see its northern pole. But the Webb images hint at an intriguing brightness in that area on the top of this image. But there's so much more than only Neptune in this picture. For instance, do you see the bright object in the upper left? What's that? That's Neptune's moon, Triton. It's a very bright point of light, and it has the signature diffraction spike seen in many of Webb's images. Triton is an unusual moon. It's covered in a frozen sheen of condensed nitrogen, and it reflects an average of 70% of the sunlight that hits it. This is why it looks so bright in the near-cam images. Actually, it far outshines Neptune in this image. Why is that? It's because the planet's atmosphere is darkened by methane absorption in the near-infrared wavelengths. The history of Triton is a complex one. Dynamicists think this moon was originally a Kuiper Belt object that later, due both to gravitational and non-gravitational processes, was eventually captured by Neptune. This might serve as an explanation of why Triton orbits Neptune in an unusual backward retrograde orbit. When it comes to the rings, this image is amazing. From the outside to the inside, we can distinguish the Adam's ring, the most studied of the 5 main rings on the planet, named in honor of John Couch Adams, who independently predicted the position of Neptune from Leverrier, the Arago ring, the Lassell ring, and the Leverrier ring. It's also possible to distinguish the Gall ring, named in honor of Johann Gottfried Gall, the first person to observe Neptune with a telescope in 1846, only 1 degree from the position calculated by Leverrier and Adams. The other visible moons are, from left to right counterclockwise, Galatea, Naiad, Thalassa, Larissa, Proteus, and Despina. These moons are really interesting objects. Despina, only 27,700 kilometers or 17,200 miles from Neptune's clouds, orbits every 8 hours. Its diameter is about 150 kilometers or 90 miles. It's irregularly shaped and shows no sign of any geological modification. Despina circles the planet in the same direction as Neptune, rotates and remains close to Neptune's equatorial plane. Proteus is an irregular moon. It's the second largest moon on the planet after Triton. Despite its large size, Proteus was not discovered until the Voyager 2 flyby in 1989. The moon, in fact, orbits very close to Neptune, and therefore it is undetectable from Earth, since its light is lost in that reflected by the planet. Furthermore, Proteus is one of the darkest objects in the solar system. It reflects just 6% of the light that hits it. The surface of the moon shows no sign of geological activity, neither recent nor past. Instead, numerous craters are visible, the largest of which, Pharos, has a diameter of 250 kilometers and a depth of 15 kilometers. Thalassa and Naiad was most likely formed from fragments of Neptune's original moons, which were smashed by the disturbances caused when the ice giant Neptune captured Triton. Thalassa is unusual for an irregular moon because it is roughly disc-shaped. Both Thalassa and Naiad circle the planet in the same direction as Neptune rotates and remains close to Neptune's equatorial plane. Thalassa's orbit is slowly decaying due to tidal deceleration and may eventually crash into Neptune's atmosphere or be torn apart and form a planetary ring. Galatea is irregularly shaped and shows no sign of any geological modification. Last but not least, Larissa's orbit is mostly circular, but it is slowly spiraling inward and may eventually impact Neptune's atmosphere, or the gas giant's tidal forces may break Larissa apart to form a planetary ring. The moon orbits Neptune in about 13 hours and 20 minutes. Do you like Neptune's image? Well, that's not everything. James Webb also took its first image of Mars, the red planet. Mars is so close and so bright, and Webb is so sensitive. This is the reason why researchers had to employ special observing techniques to avoid what's known as detector saturation, a phenomenon caused by too much infrared light that blinds the sensors. They used very short exposures and filtered the light that reaches Webb's instruments. The telescope's first images of Mars show an area of the planet's eastern hemisphere. The images show amazing surface features such as dust layers, craters, and dark spots, including the Hellas Basin, Syrtis Major, and Huygens Crater, where the Perseverance rover is currently at work. They show variations in temperature at different latitudes and times of day. You can clearly see warm regions where the sun was almost directly overhead, as well as cooler areas in the northern hemisphere and near Mars's polar regions. As you can see, despite the fourth observational mode being switched off, Webb is still able to amaze us. We just have to wait and see how engineers will fix the problem. We'll keep you updated. That's all for this video. Thanks for watching. What do you think about Neptune's and Mars's images? Let us know in the comment section below. I'll see you next time on the channel.